Hello friends, welcome to Kavita's classroom, and by now I hope you have got to know about the trend of 6 cost structures, 3 totals and 3 averages. But today we are going to talk about the heart and soul of this chapter, that is the marginal cost. Actually, it's the marginal cost which derives the rest of the costs. What is it? What does it mean? How can we have the relationship established between many other costs, and how to present the same in the diagram? For knowing this, let's proceed. So, marginal cost. The moment we have the term marginal, we know we are talking about additional. Additional means for every next unit which the producer is producing, what cost is he incurring? So the cost which he is incurring is the sum total of total fixed as well as variable, right? So let's understand how is it different from fixed, variable and all, right? Marginal. This formula we have read in productivity also, marginal product also, marginal utility also. So what was it? At nth level, it is TP at nth minus TP at n minus 1th. Similarly, MU at nth is equal to TU at nth minus TU at n minus 1th, means the preceding one. On a very similar note, MC at nth is equal to TC at nth minus TC n minus 1th, means whatever is the change brought in the total cost on account of the production of the next additional unit, that cost is called the marginal cost. We do have another formula when we are not given the total cost of 2 consecutive values. So we would have to use this very formula. When some intermittent data is given, like the total cost of 5 units is this, right? So, and fifth unit and eighth unit. So what is going to be the marginal? So in this case, we are not given the fifth and sixth data. We are given the data of fifth and eighth. Hence, change in the total cost versus change in the quantity. This is going to be the other expression of the formula. And this is a favorite of all the paper setters. They often use this formula for 1 marker question. Now, let's proceed. We have already talked about these first three columns. This is the number of output, and fixed, variable and total we have already talked in the previous modules. So let's talk about marginal. How do we calculate marginal? It's simple. TC, and we have to just keep on subtracting from the previous value. So if we talk about this very level, what is MC at this very level? 42 minus 38 gets you 4. What is MC at this level? 72 minus 56 gets you 16. So formula is clear to us that it is the difference between 2 consecutive values of the total cost, right? But let's understand its nature. To understand its nature, just have a rational look on this table. If we are producing first unit, we need to invest in 10 units in fixed cost, right? And 10 in the variable to make it 20 as the total. And this is 10 as marginal Y. Because when we are not producing even, we still have the money invested in fixed assets. So the total cost at 0th level is 10. Right. So from 10, it is now increased to 20 when we have produced first unit. Hence, the marginal means the next unit which we have made, means the first unit which we have made, that has given us the additional cost of 10 units. Right. And when we talk about this additional cost, mind you, this fixed investment has been done once for every next unit. We are not spending any other extra value. Right. So this remains the same, but this keeps on moving as per the quantum. Right. It keeps on changing. Initially, the productivity is higher, so it increases at a slower pace and then it increases at a higher pace. Right. So when we talk about marginal, just see how does it look like. It takes the shape of U again. And mind you, in this chapter, it's not merely MC. We have AC as U, AVC as U, MC as U, right? So all these U shapes and inverse S shapes. Inverse S shapes are with TC and TVC. All these five shapes are governed by law of variable proportions, which simply says that initially when we are beginning, when the fixity of fixed assets is there and it's always productive to add on the labor, then the costs keep on falling. That's why at the initial stages productivity rises but the costs fall. But after some time productivity starts falling and the costs rising. Right. That's why if we are able to recall, this is, AP, MP, these are the inverted shapes for the productivity, right? So this is AP and M is a naughty chair. Says you're moving up, I'll move up. You're moving down, I'll move down. So M is this. So as MP and AP are moving down, if you talk about AC and MC, you would see this as the mirror image. They are going up. So this is going to be AC and this is going to be MC. So there is a clear and the opposite relationship of productivity with respect to cost. If productivity is higher, the cost falls down. But if the productivity starts falling, the costs start rising. That's why we say they are with respect to each other, in sync with each other. They are the mirror images of each other. Right. And when we talk about MC means initially we are beginning with say 10 as the value here. So for some levels, this value will fall. So it's falling from 10 to 8 to 6 to 4 to 4 again. Means here this U shape is giving it constancy, means stabilization for a while. And then it starts moving up 6, 8 and then 16. So it's a clear relationship that productivity and MC are opposite to each other. I hope you are able to have it clearly done. And this also gives me the opportunity of telling you that when you talk about, say, this six is the marginal cost. You can find out this marginal cost from this table, not from one place, but from two places. Because marginal cost is the rate of change of variable as well as total cost. When we are producing every next unit, after first unit is made, we are producing every next unit. We are only adding to the cost of variable cost, right? Variable inputs cost is added. Fixed cost remains the same. And hence, so this 6 you can find as the difference between these two, means the consecutive 2 units of total cost, as well as these two, the consecutive 2 units of variable cost, right? So this will tell you that MC is nothing or TVC is nothing but the sum of all the MCs. Every additional cost which is being done is actually variable in nature, because plant and machinery has already been installed at 0th level. Right. So let me show you this. TVC is sum total of MC from this table again. So TVC is 10 here. It's the sum total of MC 10. Okay. Next, if we add 8 to this 10, we get to have 18. See. When we add 6 to this 18, we get 24. And when we add 4 to this 24, we get 28. So what is TVC? Variable cost is found by summing up all the marginal costs. Marginal costs are nothing, but they are variable in nature. Right? And for numerical perspective, this is a clear relationship you would be working on. The most important point is at 0th level, total cost is never 0 and fixed cost is never 0. This you have to keep in mind. And then when you talk about MC value is the difference at TVC or TC, both. Right. So this is the relationship. If it is clear to you, you are able to crack any numerical given in this chapter. So when we talk about the graph, pictorial presentation of Marginal cost, this is U-shaped. U-shaped means initially the productivity is increasing, hence the cost, every additional cost is falling, and then the additional cost or the cost of making additional goods is rising. And this gives the scope of one more expression, that when we say TVC is the sum total of MC, we do have a relationship that area under MC is TVC. Area under MC is TVC. We did this similar type of relationship in the previous expression also, right? In the previous modules. Now let's understand. When we are making 1 unit of production, this is my cost, right? So I have spent this much. When I'm making second unit also, this is the second unit's additional cost. This is the third unit's additional cost. But what is the total cost, total variable cost so far? So this whole area becomes the total variable cost, which is found by adding up all the marginal cost. So area under MC curve is TVC curve, right? With this, we are clear about the relationships, and now it's easy to understand this, that MC is the rate of change of TC as well as TVC, which is very, very, very important and crucial to understand from numerical perspective, right? Then we have the relationship between average marginal and total cost. So should we brief up once again? If we have to make the diagrams in a very fast manner, this is total fixed cost. This is total variable cost, right? And this is total cost. When we talk about averages, how do averages look like? Average fixed cost is rectangular hyperbola. Average variable cost looks like the Nike sign, right? And average cost is in between these two because that's the sum total of average fixed and average variable. So this goes this way, right? When we talk about the marginal needs the bottommost points of AC and ABC, and again it's U-shaped, so this goes like this. So this is the pictorial presentation. If you're done with this picture, you're able to give the subjective answers also. Like when MC is falling, is AC falling? When MC is rising, is AC also rising? MC falls only when AC falls, this and that, this type of expression. So when we talk about the relationship between AC and MC, very clear, AC and MC, we have already seen this. You take up only this point. AC is U-shaped and MC again is U-shaped, but it is moving from the minimum point of AC. Right, this is how it looks like. Right, so how do we establish the relationship? When MC is falling, AC falls. When MC is rising, AC is again rising, but there is a stretch. See, in this stretch, what happens when AC is falling, MC starts rising, right? So if we say the question is when AC falls, MC falls. Is it true or false? That becomes a false statement, and we have to show this diagram and we have to refer to this very area. That in this area, AC is falling, but MC has begun rising here from. Right. So this way, the questions of true, false, and justify can be done referring to the picture. So what is the relationship between AC and MC? When AC falls, MC is lower than AC. So when AC falls, till it is falling, right? MC is below it. This is below it, right? Then we have a point of intersection, and MC cuts AC at its lowest point. This is the lowest point. We use this point for demarcating where to go from, where MC would be intersecting from. And when AC rises, MC is greater than AC. So from this point onwards, when AC rises, from in this diagram, when AC rises, MC is greater than AC. Similar kind of relationship we do see with respect to MC and AVC also. If you remember the master diagram, here we made the master diagram, and in this also we tried talking about the similar relationship of MC and AVC, that MC cuts AVC from below at the minimum point. So on a very similar note, this relationship also goes. When AVC is falling, MC is below it. When AVC is rising, MC is above it. And MC cuts AVC at its lowest point. So this type of relationship you can give, you can talk about the mathematical expression of what is the relationship between MC is equal to TCN minus TCN minus 1, as well as TVCN minus TVCN minus 1, right? So with these points of references along with the diagram, you can just give the relationship for 3 to 4 marks. Then comes the relationship between TC and MC. Total cost is this and MC is this. So we have it in 2 frames. Till MC is falling, TVC is rising at a lower pace, decreasingly. Why? Because till this point, the productivity is higher. But afterwards, when MC starts rising, the total cost also starts rising increasingly at a faster pace. So this is told in 2 frames, till it is falling and till MC is rising. Fine. So this is again the master diagram, and if you are done with this picture, you are done with all the clarity and all the expected answers. You need not worry about it. It's recommended to all the students to draw this picture at least 4-5 times to understand the nature of curves. But for AFC, rest all the curves are U-shaped in nature, but how to make where from these will go and which is going to be the point for MC to intersect AC and AVC is a major deal, because those points are checked to check the correctness of the diagram made by the students. With this, we have come to the closure of the chapter. This chapter is often taken to be little hard by the students, but with some of the practice of making diagrams and numerical solutions, you can just overcome all your hardships. With this, I close this chapter, this session. God bless you all. Bye-bye.